This is the second part of video about Unit 10, Occurrence and Extraction of Metals. So last time in the first video, we have mentioned about the first three methods, including physical method, heating the metal or unknown in the air, and also heating the metal oxide with some of the reducing agents. So today we will move on to talk about the last method called electrolysis. Electrolysis 點解? So to understand it, okay, so now let's use the table, okay, in your note, page 15 as an example. So just a revision. Gold, okay, a very stable metal, okay, so themselves exist as free element. So you can simply use physical extraction to extract them out. For silver and mercury, okay, so of course there's one more, which is platinum, can also use physical method. For the next two metals, silver and mercury, okay, so they are more reactive compared to platinum and gold. So they will exist as compound. So most likely they can be mercury sulfide, mercury oxide, or silver sulfide, silver oxide. To extract them, that will be quite easy. Simply heat them alone in the air will be fine. Okay, so that will be the corresponding equations. So heat sulfur in the air, and then sulfur will become sulfur dioxide. Heat oxide in the air, and the oxide will directly change into oxygen gas. And the next, okay, that will be the other four metals. Okay, these four. So you have to extract them by using reducing agents. Now have a look about the reactivity series. Okay, so this is in the order of reactivity series. So if, let's say for example, zinc compared to the other three metals in these four metals is more reactive. In other words, it means that its compound will be more stable. Okay, because reactive metal would like to donate electron and become compound, become ionic compound. So that's why if we would like to extract the metals from their corresponding compound, then we need the help from the reducing agent. So now here, we have to specify if the metals exist as sulfide, okay? So we must change them into oxide first, before further reduction by the reducing agents. So this is not the same as the other two metals, like mercury and silver. Because for mercury and silver, no matter they are sulfide or oxide, they can be extracted easily by heating in the air, simply, okay? Very easy method. But for these two sulfide, you have to heat them in the air first and then by reduction. So now, these are talking about how to extract them by using reducing agent. These are all about heating with reducing agent because they are not the metal sulfides. So that's why you can use this method directly. And then lastly, we will talk about electrolysis, which is used to extract these five metals. So electrolysis of these five metals must be happen in molten state. How come? Let's have a look. So let's use electrolysis of aluminium as an example. So aluminium ore mainly contain aluminium oxide, which is a ionic compound. So if you remember, ionic compound cannot conduct electricity in solid state. So that's why if we would like to decompose it into the corresponding elements as aluminium and oxygen, okay? So oxide, when electrolyzed, so they will become some substance you can see in the nature that will become the oxygen gas. So then, what if you would like electricity to pass through? One way is to heat it to become molten. Now, in this case, there is something added. Now, bauxite containing aluminium oxide, and now it is dissolved in a cryolite. So what is cryolite? Cryolite is something that can reduce the melting point of bauxite because bauxite is a ionic compound. It has very high melting point. So cryolite here is to reduce the melting point of aluminium oxide. So once the melting point of aluminium oxide is reduced, that can save energy and save the cost. So that's why I would like you to write down in your notes. cryolite reduces the melting point of aluminum oxide. So that's why cost is reduced. Okay. Now, let's have a look about how electrolysis carry out in this case. Firstly, for aluminum oxide, when you become molten state, so we use the symbol L to represent it. It's not AQ because there's no water. Oh, sorry, you don't understand AQ at that stage. So for physical state in this chapter, you learn about G stands for gas, L stands for liquid, that means the molten state, okay, or solid, okay. So in this chapter, you just need to learn these three. So once it become molten, the liquid state, then the ions become mobile. So we have aluminum ion and oxide ion. Now for this tan, for this electrolytic cell, okay, is a tan that can help you to separate, to electrolyze them, and then to get the aluminum. So firstly, there will be the positive graphite electrode. This is graphite, which carry positive, and then is a tan, which is negative graphite electrode. So this tan, okay, this container carry negative charge. And then what will be next? Now, because aluminum ion carry positive charge, so it will be attracted towards the tan, which is negative. Okay, so it may be attracted to here, it may be attracted to there, it doesn't matter. Because aluminum, once they attracted to the negative electrode, so this electrode, okay, this one, will provide some electrons. So aluminum, they will be changed into aluminum metal. So in this case, aluminum ion, once attracted to here, so remember, there are many electrons from the electricity supply. So once they get the electron, they will become aluminum. And because of the high temperature, they are in molten state. Okay, so after electrolysis, so we will get aluminum. And then for oxide, because it carry positive charge, so they will be attracted towards the graphite, positive graphite. And then they will become oxygen gas, and then bubbling off. So for electrolysis of ionic compound, we just separate the corresponding elements into the corresponding substance. So one thing, remember, you have to carry out electrolysis under molten state. And then the second thing, you should know that they change into their corresponding elements that can exist in the nature. So remember, after electrolysis, there's no longer oxide. Okay, this is wrong. Okay, and it's no longer aluminum ion. That is wrong. Okay, they change into something stable and can be exist in the air. So that's why we can mark it down. Aluminum oxide in molten state, after electrolysis, they will become the corresponding element, aluminum and oxygen. And then let's say for sodium, okay, because they corresponding to the 5 most reactive metal. After electrolysis, they will become the corresponding element, just like sodium. And chloride will become chlorine gas. Okay, so for example, okay, we have potassium chloride. Okay, so after electrolysis, they will become the corresponding metal with the gas. So all the chloride will become chlorine. If they are oxide, then they will become oxygen gas. Understand? Okay, so just become the corresponding substance. And then for the physical state, it doesn't matter a lot. But for these metals, if you use L to represent it, or you use solid to represent it, it doesn't matter. They are just referring to the physical state of the metal at different temperatures. So if I say solid, we are talking about at room temperature. If you say L, it means that it's under the molten state, under the hot, very high temperature. So it doesn't matter a lot. But normally for physical state, we write them. If we are talking, for the products, very often we talk about the physical state under room temperature. So that's why I print S for you. Okay, so but in public exam, I don't think it's a matter, okay, to write any, whether solid or liquid, it doesn't matter a lot. Okay, so do you think electrolysis can be used to extract the other metals? So of course, yes. Okay, electrolysis is the most powerful method. Okay, it's the most powerful method. So it can actually separate all kinds of metal from their compounds. But how come we have to learn that different kinds of methods to extract metal? Is because electrolysis is actually the most expensive method. It involves electricity, which is quite energy consuming. So that's why we say electrolysis is much more energy consuming and also expensive compared to the other methods. So that's why normally if we have a simple method, we just use the simple method. Okay, just like just use a physical method, heating alone, or extract it by using reducing agent. Okay, so now lastly, I hope that you just use less than 4 minutes to have a look of this video talking about the electrolysis of aluminum oxide to make you have a better understanding about the extraction. Okay.